nuclear explosions between the gas clouds and the torches rapidly put up wild mixtures in the vicinity of the ASP. The space occupied by the mixtures easily spans thousands of light years across and keep expanding. The fate waiting for all the torches can be anything. For a torch that never hits anything, it could only get older and older until it completely cools down. A torch may collide with another torch. The colliding torches may be from different generations. A torch may also collide with another gas cloud. The outcome of all these collisions varies. Materials may join to form a bigger mass or clash into fragments of different sizes. Some torches may miss each other, but at a close distance, if their total mass causes enough strong gravitational force between them, they will lock each other up to form a rotation group. If the gravitational force is not strong enough, each of the torches would just alter its moving direction and fly away from each other forever. Of course, all these collisions or gravitational locking up may also happen to multiple objects. After these objects join into a single array of flying objects in the heavens, this array continues to drift in the space. With respect to the ASP, the radial direction may either point away from the ASP or toward the ASP. Any movement that is not on a line that is crossing the point of ASP can be regarded as some sort of tangential movement. When an explosion occurs, only two fragments out of many can strictly move along a radial line. The rest would move along different tangential lines. Each of these lines finds different points to cut across a different radial line. This must cause a problem of crowdedness for those materials that would not go to the ASP, but then eventually go crossing a certain boundary line. Suppose some explosions simultaneously happen among the gas clouds on an imaginary circle. While some of the fragments leave the circle, some fragments are moving to fill up the space within the circle. But they would eventually move toward an even bigger circle if no collision would have stopped them. We cannot help to ask what happened when they all reach the bigger circle and just stay there. Now, let us have a spherical thin shell, inside which is some homogeneous but loose material. If all this material is pushed to the surface of the thin shell and evenly spread there, we define the crowdedness so caused as material quantity per unit area. If we compare between several shells of different sizes containing the same kind of material, the bigger shell will end up with higher crowdedness on its surface. Numerically, for example, a shell having a radius 5 times as large as the smaller one would also end up with a crowdedness of 5 times as high as the smaller one. What all the explosions are doing is to push the original hydrogen materials away from the ASP and fill up spheres of ever-increasing radius with these materials. The majority of these materials would have been burning torches now. As these torches move further and further away from the ASP, or towards the bigger spheres, they would all join to increase the crowdedness there. Materials crowding together but spread with a shape conformed to a shell naturally forms a sheet or layer in space. Previously, we assume all materials being pushed to the surface of a sphere all at one time. This is only for convenience in mathematical analysis. Any physical process needs time. Besides, each explosion also sends some materials toward the direction near the ASP. Therefore, we can expect that when a layer forms itself on a bigger circle, some layers have already come into shape on some smaller circles inside this big one. Since the layers in some inner circles have arrested some materials, the material crowdedness on the bigger circle is naturally less than what mathematics lead to. The randomness caused by those explosions and collisions must also disallow the appearance of tidy arrangement of layers. So layers must end up with fragments of different sizes, with some being closer to each other, while some are farther away from some others. The chaotic violent movement of all heavenly objects easily enables any fragment of layer to be consisted of any single object or any random combination of the objects that these pictures may suggest. Random as the combination may be, statistic must make fragments farther from the ASP show two characteristics. First, they are more dominated by younger materials. Second, they are more massive because of the mathematical outcome of higher crowdedness for a bigger sphere. With more and more mass, they serve as the true agents to bring Hubble's law into reality. Momentum accumulation of many generations of fusion explosion is the key of Hubble's law. However, there is a catch. Let's align many gas clouds of the same size on a straight line. Suppose each cloud would split into 6 fragments of the same size upon the explosion, and one of them must travel strictly on the direction of the previous torch that hit its parent cloud. Although each newly produced torch moving on the same line will have higher and higher speed, this newer and newer speed must eventually approach an upper limit. However, somewhere on the line, the breakthrough must sooner or later appear because of the inevitable of higher crowdedness for a bigger sphere. When a group of torches moving above the speed limit form their own material clusters, they will enable the newer torches to travel at an even higher speed. Generation after generation, this kind of momentum escalation makes no speed limit being possible in the universe. The concept of the existence of a speed limit in the universe, deduced by relativity, is not a physical reality. It is an outcome of erroneous mathematical operation. If someone is interested in discussing this topic, they are cordially invited to visit our webpage, www.huntoon.net. Some sizable awards are also posted there to make the discussion more interesting. At this point, we would like to bring up another cosmic structure to our picture, which is called filament. Filaments are formed in the similar mechanism that produce the layers and clusters we have been so diligently discussing all along. However, there are layers and clusters starting at locations centered on points away from the ASP. We will continue this topic in a different episode.